Today we are going to continue the problem 5.9 of Griffith third edition Introduction to Quantum Mechanics. This is part 2. In part 1 we have seen the for spin off particle we have seen the degeneracy and the energy level. Here now we are going to see the same thing for a spin one particle, for which we are going to use a Clips cordon construction. In previous case, it's very simple because it's a spin off particle. So in spin one particle, when both S, M, we know that is S is the spin quantum number, uh, M is the magnetic quantum number. So both are zero in this case. Then the wave function will be, spin part of the wave function will be 1 over square root 3. Here, what are the possible value of 0? That is, if spin is 1, then you will get minus 1 to plus 1, including 0. So this will be plus 1 minus 1. That is, you get plus 1 minus 1 plus minus 1 plus 1 minus 0 0. Here you can notice that when you are swapping the state 0 1 to, that is minus 1 plus 1 to minus 1 as minus 1 to plus 1, even if you swap this state will not change because you have plus. So this is the symmetrical one. Here also, if you change 0, nothing will happen. So it is a symmetrical one. Whereas in the case of spin-off particle, we have seen this is the anti-symmetric. Singlet state is anti-symmetric. Here is symmetry. You can use Clips cordon coefficient, which I have explained in my theoretical lecture. Also, the table itself available in so many standard textbooks. Then we will come to triplet state. In the triplet state, you have one, S is 1, M is 1. So then you can have a linear combination. That is 1 over square root 2 get 1 0 minus 0 1. Here if you swap the state, that is 1 and 0, then you will get negative signs. This is anti-symmetry. Similarly, for 1 0, then you will get 1 over square root 2 plus 1 minus 1, because this will be 0. Total spin is 0 minus minus 1 plus 1. If you swap this state, you will get sign will get changed. So this is also anti-symmetric. Then what about 1 minus 1? Then it will be 1 over square root 2, 0 minus 1, minus minus 1 0. If you swap this particle, then naturally you will get negative sign. So this also, all three are anti-symmetric. It's a triplet state, but it is anti-symmetry. In the case of spin-off particle, we have seen triplet state is symmetric, but singlet state is anti-symmetric. Here it is vice versa. You can easily calculate this, whether it is plus or minus, using Clips cordon coefficient. Now we will move on to next one. Just now we have seen the singlet state and doublet, sorry, triplet state. Singlet state is, in our case, it is a symmetrical one. Triplet case is anti-symmetric. Now we will see the quintet state. Previously we have seen when when S is equal to 1, we have seen triplet state. When S is equal to 1, what will happen? When X is equal to 1, M will be, MS will be 1 0 minus 1 we have seen. Here in this case s is equal to 2. Then that is simply we can say m is equal to 2s plus 1 state. So s is 1. So 2 plus 1, 3 state. Similarly here s is equal to 2. Then m is equal to 2 into 2, 4 plus 1, 5 state. So it will start from 2, 1, 0, minus 1 and minus 2. So just to keep it in your mind, then we will move on. So when total spin is 2, then you have 5 different state. 2, 1, 0, as I said. We have 2, 1, 0, minus 1, minus 2. So 2, 1, 0, minus 1, minus 2. So here 2 you will get vector plus 1, plus 1. So this is the symmetrical one. Remember that this is a symmetrical one because there is a plus sign. Then when m is 1, you will have a linear combination of 1 over square root 2 plus 1 0 0 plus 1. Even if you swap this particle, nothing will happen because it's a plus sign. So this is also a symmetrical one. Then what about 2 0? When it is 2 0, you will get as per Clip's Cardan coefficient. This coefficient is 1 over square root 6. Then the get vectors are plus 1 0 0 plus 1. Then 2 times 0 0. So all are symmetrical one. Even if you swap this, nothing will happen. Sign will not get changed. Similarly, for 2 minus 1, it is 1 over square root 2, 0 minus 1, plus 1 minus 0. Here also nothing will happen. So the entire thing is a symmetric one. So 2 minus 2, which is equal to get minus 1 minus 1. So you can calculate this parameter using the Clip's Cardan coefficient, which I have explained uh, theoretically. So the all the 5 states are symmetry. So totally how many states you have? One singlet plus 3 triplet and 5 quintet. So totally you have 9 different states. Then using this we will move on further. If the particle are distinguishable, then the ground state psi 1 multiplied by get Sm. Then what will happen? We have seen there are 9 spin state. So degeneracy is 9, which is having same energy. So you have the first particle at energy level k, second one at k, then total 2k. We know the k is equal to pi squared h cross squared over 2ma squared. 2ma squared. So this is 2k. Similarly, what will happen to the first excited state? So first excited state psi 1 to get Sm or psi 2 1 get Sm. So here, since particle are distinguishable, this and this is different. So naturally here you have 9 state, here you have 9 state. Totally you have 18 state. What about the energy? 1 squared plus 2 squared. Totally you have 5. So 5k. Then second excited state is psi sub 2 to get Sm. So here the particle are distinguishable, but however both are at the same energy state like psi 1 1. So this get Sm, that is a spin state has 9 state. So degeneracy is 9. Then what about the energy level? 2 squared plus 2 squared. which is equal to 8. So naturally this will be 8k. Similarly, what will happen to third excited state? Psi 1 3 get SM or psi 3 1 get SM. Here particle are distinguishable, so naturally this will be different from this. So totally you have this uh, spin state is here one 9, here another 9. So total degeneracy is 18. Then what about the energy level? That is 1 square plus 3 square, which is equal to 10. So we have taken 10. Then we will move on to identical particle. Now we will see for identical particle, which is very very interesting one. You can see the ground state is psi sub 1 1 s m. You remember that here we are dealing with spin 1 particle, spin 1. That means is boson like. Spin up only fermion, spin 1 is boson like. So boson like means the wave function must be symmetric. That is either facial wave function or spin wave function must be. That is combination of facial wave function and spin wave function uh, must be symmetrical one. Say for example, in this case, psi 1 1 both are at the same energy state. This is symmetry naturally. Then this must be also symmetry in order to have total wave function symmetry. When this will become symmetry only if you have, maybe I will use different color. When you have singlet is a symmetrical one plus one quintet, that is 1 plus 5. So 6, degeneracy is 6. As usual, the energy level is 1k plus 1k, 2k. Now we will see for first excited. First excited state, the wave function is linear combination of 1 over square root 2 psi 1 2 plus psi 2 1 and get Sm, or 1 over square root 2 psi 1 2 minus psi 2 1 get Sm, which is equal to this. We will see how it is. See here it is the symmetrical one. You can see. So this must be also symmetry. As I said, when it is symmetry, your degeneracy is 6. We have seen the previous case. Then what about this? This one, you have anti-symmetric wave function. I will simply write anti-symmetry. Then this must be also anti-symmetry in order to make symmetrical one, anti-symmetry. So only the triplet state is in this case anti-symmetric. So 3 plus 6, total degeneration is 10. Then 1 square plus 2 square is equal to 5. So I have written that 5k. Then we will move on to next case. Now we will see it for second excited state, that is psi sub 2 2, that get vector Sm. Here it is clear that it is symmetry, is a symmetrical one. So naturally this also must be symmetry. So what are the possible symmetrical S and M? That is you will have symmetrical one, means you have singlet is a symmetrical one here, and one quantities symmetrical one. So 1 plus 5, which is 6. Then what is the energy level? 2 square plus 2 square, which is equal to 8. 8k. Similarly, what about the third excited state? 1 over square root 2 psi sub 1 3 plus psi sub 3 1 SMS, or 1 over square root 2 psi 1 3 minus I 3 1. Get SM. So now you can see this is the symmetry. So naturally, this must be symmetry one. So here symmetry, that is spin part symmetry means you will have one singlet. Singlet is a symmetry and quantity. So singlet is 1 plus quantity 5, 6. Then what about this? This is anti-symmetry. Anti-symmetry. So naturally, this must be also anti-symmetry in order to make it symmetry. So you have one triplet state, which is anti-symmetry. So that is 3. So 1 plus 5, 6, 6 plus 3, 9. So this is 9. Degeneracy is 9. What about the energy state? Energy state is here 1 squared plus 3 squared, which is equal to 10. So this is the 10. So this is our understanding about singlet and doublet. Thank you very much for watching my video and supporting me continuously. Thank you very much.